Have two blocks, A, mass 3 kilograms, B, mass 2 kilograms. Before collision, A moves to the right with speed of 10 meters per second. And block B moves to the right with speed 5 meters per second. Okay, after collision, block A moves to the right with speed 6 meters per second. So we call this U1, the final velocity. We use U to denote it. And block B will move, of course it should be moved to the right and with some unknown velocity U2. Now what we want to do is to see if the collision elastic or inelastic. Okay. So remember, how can we tell the collision elastic or inelastic? From last problem, what we actually want to look at? The kinetic energy. We try to find out the initial kinetic energy and final kinetic energy. Okay? And compare them. If the two quantities are the same, it's elastic. Otherwise, it's inelastic. But there is a question here. If we want to calculate kinetic energies, we need to know all the velocities. But here we don't know the final velocity, U2. So how can we deal with this? Okay, we can solve for U2 by applying momentum conservation. Okay, so because for any kind of collisions, elastic or inelastic, you always have the momentum conservation. So that one equation can help us to find this unknown quantity. Okay, so that's what we want to do. Let's write down the equation: m1v1 plus m2v2 equals to u1 m1 u1 plus m2 u2. If you substitute the number, you get 3 multiplied by 10 plus 2 multiplied by 5 equals to 3 multiplied by 6 plus 2 multiplied by u2. So this, of course, can give you u2. What do we get for u2? 11 meter per second. Okay. So that's u2. So now, of course, with knowing all these velocities and masses, we can calculate K initial and K final. K initial should be 1/2 m1 v1 squared plus 1/2 m2 v2 squared. So this will be 1/2 multiplied by 3 multiplied by 10 squared plus 1/2 multiplied by 2 multiplied by 5 squared. Okay. So this will be 150 plus 25. So 175. Okay. So that's the initial kinetic energy. Now let's look at our final kinetic energy. It should be 1/2 m1 u1 squared plus 1/2 m2 u2 squared. Okay? And this will be 1/2 multiplied by 3 u1 6 squared plus 1/2 multiplied by 2 11 squared. So this is okay, 54.5 plus 121. So it's again 175. Okay, so this collision is it elastic or inelastic? Elastic. Okay, so you can write since K initial equals to K final, it is elastic. Okay.
Can you go back to where the 11 came from? Where you got 11?
I solved this equation. The momentum conservation. Okay. So you can just check that if you solve this equation here, you have
40 minus
40,
18.
you have
Divided by
18. So it's 22 equals to 2u2. So it's 11. It's elastic because after you calculate the initial kinetic energy and the final kinetic energy, you found that they are the same. Both of them is 175. Okay? So here, again, the only key is that I didn't tell you U2 directly. So you have to solve U2 from the momentum conservation first to get U2. And then you can calculate the final kinetic energy. Okay? Any question here? And please remember that you can always use the momentum conservation for any collision process. Okay. Now,